Previously, we've seen how Kamu and Open Data Fabric can be used to build decentralized data supply chains, where every stage is owned and maintained by a different person or organization. In this video, we'll see how Kamu creates verifiable trust between the participants in order for such collaboration to function. We rarely talk about data trustworthiness in the enterprise setting. We do worry about correctness, but because employees of a company usually share the same incentives, the trust is implicit. Things get a lot more interesting in a decentralized setting, as you have to account for malicious intent. For people around the world to be able to collaborate on data efficiently without personally knowing one another and sharing same incentives, we had to solve the collaboration problem in zero-trust environment. In the last video, you've seen the clear separation Kamu makes between root and derivative datasets. Let's look at how trust works in each of them separately, starting with the root data. Imagine I was very into meteorology and started to record and share hourly temperature readings outside of my window. This makes me a data publisher, but as a consumer, how can you trust my data? First factor is reputation. Your degree of trust may go up if you know me personally or see other people in the community trust me. An affiliation with a government or a university would also improve my credibility. Another possibility is audit. You could send someone to assess my methodology and see if my tools are calibrated. This requires some kind of third party, so it doesn't scale well and always leaves the question of who watches the watchman. A much better option is cross-validation. You could find a nearby weather station and see if my measurements are similar to theirs. A step above that would be to continuously rely on a group of independent publishers, comparing their data, discarding, and possibly penalizing the outliers. As you can see, the source data is inherently subjective and under complete control of its publisher. The role of Kamu is to provide you the tools to perform a combination of the above checks. Using inspect lineage command, you can quickly understand which root datasets you're relying on, no matter how many transformation steps data went through, and see if they belong to reputable publishers. Note that in our previous example with COVID-19 daily case numbers, even though the source data was coming from the government data portals, I was the actual owner of the root dataset and the one ingesting data. This makes me the weak link in a trust chain, and a root dataset provided directly by the CDC would be far more trustworthy. After you've found the root datasets you can trust and perform some analysis, you will face another problem. When you show your results to someone else, like publishing them in a journal, how can reviewers be sure that your results were produced from trusted data? This is now a three-party, man-in-the-middle type of problem. They somehow need to be able to ask the publisher, hey, is this your data? Did it actually come from you? Answering such questions today is extremely hard. Open data publishers don't sign their data nor provide checksums of previously published data. What's worse, a lot of publishers destructively update their data regularly, leaving no way for you to tell how data even looked like on the day that it was originally downloaded. This is a huge problem. That means most of the source data today is non-verifiable and non-reproducible. Ignoring this problem and hoping that everyone acts in good faith still works most of the time, but has devastating consequences when it doesn't. Because datasets in Kamu are ledgers, there is no conflict between having real-time data and it also being 100% reproducible and verifiable. Using the block hashes just like Git commits, publishers can issue stable references to data at no cost, and in combination with data hashes, they provide a built-in verification mechanism. While root datasets provide us the solid foundation for trust, derivative datasets is where the collaboration actually happens. You've probably seen many cases when people download some open data, clean it, and then upload result to GitHub or Kaggle, claiming that it's an improved version of data from the official publisher. But it's really hard to verify that such data hasn't introduced some mistakes or even malicious information. By using it, you're placing a lot of trust in such person. The only thing you can meaningfully reuse is their scripts, which hopefully they shared. This inability to reuse data reliably and fast is the reason why every serious data project starts with trusted publisher data, ignoring all existing cleanup attempts. It's not a surprise that data scientists are still spending 80% of the time on data prep. It's a vicious cycle. In Kamu's take on data as code, you never modify data directly. Everything is done via queries, which makes collaboration on data very similar to collaborating on software. Derivative data in Kamu is inseparable from queries that produced it because, as we saw, it's totally useless without them. As we'll cover in future videos, queries have very strict properties. They are fully deterministic and reproducible, so the same query on the same inputs always produces the same result. Thanks to this, verification process takes just 2 steps. Using inspect query command, you first audit the queries to see they're correct and non-malicious. The conciseness of streaming SQL makes it a lot easier than auditing some random script. Then you run verify command to confirm the validity of data. The command will first verify the integrity of downloaded data by comparing the hashes to those stored in metadata, Next, it will replay the transformations locally to guarantee that the data was in fact produced by the declared queries. Using the recursive flag, this process can be performed on all upstream datasets in the chain with just one command. Here's another interesting way to look at this. Because all queries are stored in metadata and they are deterministic, derivative data can be deleted and fully reconstructed from only root datasets and metadata on demand. This makes derivative data a form of caching. This is a pretty amazing property that means that derivative data can be stored cheaply, unreliably, or even not stored at all, potentially resulting in massive savings, as the amounts of derivative data that we produce on the path to insight can often exceed the volumes of the original raw data. To summarize, Kamu provides you a simple, step-by-step process to evaluate trustworthiness of any data, enabling efficient reuse and collaboration. Validity of any dataset is a function of trusting the publishers who provided source data, auditing the chain of derivative queries, and verifying the integrity of data and metadata. Majority of this work is automated, and the remaining bits are a community effort. Just like in open source software, you will always have an army of your peers on your side, helping to establish trustworthiness of different publishers and auditing the derivative queries in complex pipelines.